Hey, Jonathan here at Colfax Math. Today I'm going to talk about reference angles in trigonometry, really common in integrated 2, integrated 3, algebra 2, trigonometry class, pre-calculus class. So a reference angle, usually represented with a theta sub r, has 3 attributes. Number 1, it is a positive angle. It is acute. Acute means less than 90. And most importantly, it always goes to the x-axis. So those are the 3 attributes of a reference angle. When you draw angles in trigonometry, you always start right on the x-axis here. You rotate counterclockwise. Where you stop is your terminal side. This is your terminal side here. You figure out the angle from that terminal side back to the x-axis. So right here, if your angle was 135 degrees, you'd figure out how far is it to the x-axis from the terminal side. So this right here would be your reference angle. It would be 45 degrees. It's positive, acute, into the x-axis. So if I have a first quadrant value, right here, the reference angle and the actual angle would be the same. So if I'm at 31 degrees is my angle, theta equals 31. My reference, theta sub r, is also 31 degrees. So in the first quadrant, the angle and the reference angle are the same. This is quadrant 1, quadrant 2, 3, and 4. They're labeled like that because you start here and rotate counterclockwise. If I ended in the second quadrant right here at, let's say, 150 degrees, so theta is equal to 150, theta reference is 30 degrees, so my reference angle is 30 degrees. So in the second quadrant, the way I find my reference angle is I go 180 degrees minus my angle, and that'll give me my reference angle. So 180 minus the 150 gives me my reference of 30. Down here in the third quadrant, let's say now I rotate around 200 degrees. So I start on the x-axis, I rotate 200 degrees, theta is equal to 200. Then my reference angle, always back to the x-axis, would be 200 minus 180, or 20 degrees. So if my angle is theta is 200, theta sub r is equal to 20 degrees. So in the third quadrant down here, you take your angle. So in the third quadrant, you take your angle, 200 degrees, you subtract 180 degrees from it, and that'll give you your reference angle. So again, in the first quadrant, your angle and reference angle are the same. In the second quadrant, 180 minus your angle will give you your reference angle. In the third quadrant, your angle theta, 200 degrees minus 180 will give you your reference angle. And now let's take a look at a fourth quadrant value. Make a little more room here. Whoops. In the fourth quadrant, let's say I start right here, I rotate around 90, 180, 270, 280. So my angle, theta, is equal to 280 degrees. My reference angle is always back to the x-axis. So my reference angle is going to be this angle right here, always back to the x-axis, positive and acute. Theta sub r is equal to 360 minus 280, or 80 degrees. So in the fourth quadrant here, the way I figure out my reference angle is I'm going to do 360 degrees minus my angle theta, will give me my reference angle. So the 360 degrees minus the 280 degrees gives me my reference angle at 80 degrees. So that's how you find reference angles. Again, they are always positive, acute to the x-axis. Let me just show a couple more things on reference angles. Another thing on a reference angle is if your angle theta is negative. So let's say theta is equal to a negative 150 degrees. So if theta equals negative 150, that negative means clockwise rotation from the x-axis. So that negative is saying, starting on the x-axis, you rotate around clockwise 150 degrees. That's where you end. So theta is equal to negative 150. You end right there. There's your terminal side. Your reference angle is back to the x-axis. It is always positive, acute, into the x-axis. So your reference angle in that case is 30 degrees. One last note, and I don't want to talk too much about it here. A lot of times with these angle measures, it's in a DMS system. DMS stands for degrees, minutes, seconds. So you might have something like 30 degrees, 30 minutes. There are 60 seconds in a minute, 60 minutes in a degree, just like on a clock. So 30 degrees, 30 minutes is the same thing as 30.5 degrees. Only difference between a clock is there are 360 degrees in a full rotation. So one full revolution is 360 degrees. So another problem you might see is, let's say theta is greater than a revolution. So let's say theta is equal to 375 degrees. So that's greater than a full revolution. Again, I start on the x-axis. I rotate counterclockwise, 90, 180, 270, 360, 375. So there's my angle, 375. And then my reference angle is how far it is back to the x-axis. So I subtract 360 from that to get a reference angle right here. A reference angle, theta sub r, of 15 degrees. Always back to the x-axis. If you had a really large angle, like 5,442, you would divide by 360 degrees. That would give you the total number of revolutions. And then you would subtract the integer from that decimal. Then take that decimal and multiply it by the number 360. And that would give you how far you go past the number of revolutions. So let me do that one really quick. So I already forgot what that number is, but let's say theta is equal to 5,432 degrees. I'm going to take that number, divide it by 360 degrees, and that's going to give me the number of revolutions. The number of revolutions or rotations around. So on my calculator here, I go 5,432 divided by 360 degrees, and that gives me 15.088. 15.088. So that's the number of revolutions. So 15.088. Repeating. What I'm going to do with that, on my calculator, I'm not going to write it down because I don't want to lose any of my significant digits. I subtract 15 from there, and that gives me the 0.08. So I subtracted 15, and now I have 0.088889. Now that I subtracted 15, I multiply that decimal by 360. So I take this decimal in my calculator, multiply it by 360 degrees, and I get 32 degrees. So that puts me back in degrees. I'm not 32 degrees. So when I have the angle 5,432, what that means is I rotate around 15 times, and then I end 32 degrees after 15 revolutions. So that's going to work out to be my reference angle. So if my angle theta is 5432, my reference angle is at 32 degrees. So theta sub r is 32 degrees. If this number down here worked out to be like 150, well, that would be a second quadrant value, right? So you'd rotate 15 times, then go 150, it's the second quadrant value. 150 will give you a reference angle of 30 degrees. All right, so that's a short overview on reference angles. Hopefully that'll help. I'll make another video on degrees, minutes, seconds. Reference angles are used throughout trigonometry, exact trig problems all the time. This is Colfax Math. If you like these videos, hit like and subscribe. Thank you for watching.